Okay, moving on. Let's look at the next statement. We are given not A, arrow B, and we're asked to write the inverse, converse, and contrapositive of it. The inverse, if you'll remember, is when it's we invert. Inverse, invert, which means kind of change each side, the opposite. So the first part of this conditional was not A. The inverse of that is A. Arrow, the opposite of B becomes not B. Converse, we go back to the original statement, and that's like the sneakers. That's when we move the feet, we cross them. So B takes the position up front, and not A goes in the back. All right, contrapositive is when we do both. So it's like I can take the converse right here where they're already switched, and now I can do the inverse to it. So the opposite of B becomes not B, and the opposite of not A becomes A. The conditional statement is always logically equivalent to the contrapositive. That's just something we have to know and remember. All right, a deductive system is based on what 4 things? You do not need to know this. Don't waste your time. All right, next section, part 3. Using the given conditional statement, state the logical conclusions for numbers 19 through 20. Choose from the conclusions in the right-hand column. So it's almost like we're doing those modus ponens and modus tollens, and they're telling us that this is the conditional statement. This is like the P arrow Q, and each time they're giving us another piece of information and asking us if we have enough now for modus ponens or modus tollens. Okay, so let's look at that. Number 19. P stands for it is a banana. If it is a banana, then it is yellow. So we have this statement, if P then Q, and knowing that it's a banana is P. The same part, the hypothesis happened, so therefore we can conclude Q, that it must be yellow. And that would be option E for number 19. Number 20, it is not a banana. That's like the equivalent of not P. Not P and this statement do not give you any logically conclusive data, right? There's no modus ponens because they're not the same. It's not modus tollens because not P and Q are not anywhere near the same. So therefore, this would be option D. No valid conclusion. All right, next one. It is not yellow. That is the opposite of what Q was telling. So if I take my not Q and this statement, P arrow Q, we are given the opposite of the conclusion, which allows you to conclude the opposite of the hypothesis. That's your modus tollens at work right there. And so the opposite of P would have been, it is not a banana. Now I know a lot of you are going to tell me, well, the bananas get darker and they may not be yellow and they start out as green. But based on this statement, if it was not yellow, it can't be a banana. Okay. Next time, it is yellow. It's like taking P arrow Q, and then here we are given Q. It is yellow. Just because we're looking at something yellow does not mean we're looking at a banana. So there's no valid conclusion again. And that would be option D again. All right, let's look down. Here they want us to determine if the argument is valid and what's the reasoning. As you see, we see modus ponens, modus tollens, and law of syllogism, law of contrapositive. You are not going to be tested on those, so we are just going to ignore those right now. If the argument is not valid, just write no valid conclusion. So it's up to you if you like it in words or if you like it in symbols. You'll see I'm going to translate it into symbols as well. If there is a blizzard, then school will be closed. School is not closed. Here we have a conditional statement. We have the opposite of the conclusion. So therefore, we can assume the opposite of the hypothesis. And that is a clear example of modus tollens. Number 24. If the pitcher is hurt, then the team will lose. They want to say, therefore, if the team does not lose, then the pitcher is not hurt. This is a law that we did not learn. This is the law of contrapositive. You do not need to answer this, so right now you would say no valid conclusion based only on modus ponens and modus tollens. Okay? All right, if Alex plays, then the Rams will win. Alex does not play. Therefore, we can make no valid conclusion on whether or not the Rams will win. It is not modus ponens because these do not match exactly. It is not modus tollens because these are not exact opposites.